And unfortunately with a lot of telescopes, the cheap ones, they say how much magnification you can get. There's actually a limit. Basically, you want to go to a maximum of about 50 times for every inch or 2 times per millimetre. So a 50mm telescope, you don't want to go more than 100 times because the whole image just falls apart. So you see 50mm refractor, which is something like this, should give magnification between 10 and 100. Not 675 like you see on the box. Even a big telescope this big across will not give a magnification of 675. The image will just be washed out completely. It's a waste of time. You won't see anything. If you see magnifications for a telescope of more than about 2 times for every millimetre or 50 times for every inch, you will never use it. It's just not possible. Physics won't let you. So a 6-inch telescope, a maximum of about 300 times. You can see here a 16-inch telescope can actually go to about 800. There's no way you can get almost the same magnification out of a telescope that's this big compared to one that's this big. It just doesn't work. So magnification determines what you see. The lower the magnification, everything is bigger, is smaller. So you see more of everything. As you increase the magnification, you can see, you don't see as many things, but the stuff that's in the middle, you see in more detail. It gets bigger, the magnification goes up. As you push the magnification up close to the limit, this is a globular, what they call a globular cluster. You actually can see all of the stars individually. And then as you push the magnification right up, the whole image falls apart. You can't really see anything. All the stars, you can focus as much as you want and nothing will come into focus. It will just be this big blur with little lights everywhere. And that's because the magnification has just been pushed too far, way beyond the limit. The other thing with the eyepieces, they come in different designs. So some have wide angle views, some have narrow angle. And you'll notice a lot of manufacturers, they make families of eyepieces. So they're all manufactured, they're basically brothers and sisters of one another. The advantage of something like this is, if you've got something in focus at one magnification, you pull the eyepiece out, you put another eyepiece of the same family, it's in focus. If you put in an eyepiece from a different manufacturer, it won't be in focus, you've got to adjust it again. And so if you're constantly changing the magnification, you're constantly changing the focus all the time. The disadvantage of most of these kits are that you'll get eyepieces you'll never use. You'll pay all this money for the kit, and it might have 8 eyepieces and you only use 2. You could have bought those 2 and saved a bucket load of money to buy something else. So most amateur astronomers would say don't buy a kit. If you want eyepieces of the same type, just buy them individually. Buy the ones that you know you'll use, because you get so many in the kit and you just won't use them. Waste of money. The most common is a Plossel, which is what that type there is. You get a relatively small field of view, and they're cheap. You can see from $30 you can get a Plossel. That may be this sort of size. As you go up, the eyepieces get a bit bigger, and you'll see you can actually see a slightly bigger window, so you can see more. The thing you're looking at hasn't got any bigger or any smaller, it's the same size, you just see more of it. So the window is getting bigger. As we go to another one, you'll see the window's got bigger, but the object you're looking at still looks exactly the same. You can just see more around it. So that's a wider angle. So that's another criteria with the eyepieces. Basically, it's like you can get an eyepiece, you can look through a straw, or you can get an eyepiece that you're looking through a tube, so you can see more of it. And then you go right out to some of the newer ones. They're actually at the point with these, if you want to look through, you have to actually move your head around because the eye can't see all of the field of view at the same time. You have to actually move your head around the eyepiece to see everything. Because it's bigger than what your eye can take in one go. So to summarise some of the basics about telescopes, and this is a bit confusing because even in America, the land of everything inches, they have always used millimetres. I don't know that they understand what a millimetre is, but they have always used millimetres. So a telescope aperture, in Australia they're measured in millimetres as well as inches, but generally people talk about a 10-inch telescope, a 24-inch telescope, a 6-inch telescope. So usually the aperture is in inches. The focal length this way is in millimetres. In America you might buy an 8-inch telescope that has a focal length of 1200 millimetres. The eyepiece focal length is in millimetres as well, but their size is in inches. So you would get a 1 1/4 inch eyepiece with a focal length of 20 millimetres to put into your 8-inch telescope that has a 1200 millimetre focal length. Even in America, it's the only thing I know of that they've always used metric. They have never used inches. Magnification makes the object you're looking at bigger. The field of view gives you a larger window. So if you've got a larger window, you can actually magnify it more to make the same thing fill the whole field of view. So it's sort of give and take as to what you use. But of course, generally, the bigger the field of view, the more expensive the eyepiece will be. So you can go from a $30 Fossil to a $1,000 eyepiece that will give you the same magnification. It will just give you a much better image and much broader, much wider image. So the prices can vary tenfold, even 100-fold. Practical, a few words here and there. Make people think you're smart. So now you're ready to observe. Finally, you've picked your telescope, you've got your eyepiece, you set it all up, it's got dark, you can start looking. First thing you never do, never, ever point the telescope directly at the sun. Particularly, don't ever look through it, but you really shouldn't point the telescope. You imagine all that heat coming down onto a lens, which is focusing it. You can quite easily melt the optics, break a lens, break a mirror, or something like that. Pointing it at the sun can cause severe heating of the optics, right? Not a thing you particularly want to happen. Right? You can get filters that go across the front and you can look quite safely at the sun, what they call a full aperture. It's a special material that blocks most of the light from coming in, so you can safely view the sun. If you do get a telescope and it has this little glass eyepiece that goes in behind the eyepiece to block the sun out, there's one thing you do with it. You get a nail and you hammer it through the middle of it and throw it in the rubbish bin. And under no circumstances do you ever use one of those dark sun filters, ever. Under no circumstances. Because they get, you imagine, you've got this huge magnifying glass focusing heat on that piece of glass, and you're looking at it. And if it cracks, instantly all that heat goes to your eye and you are blind for the rest of your life. In an instant like that, you are blind. You will never recover. So you never use, if you buy a telescope and it has a thing called sun on it, smash it. Don't throw it in the bin in one piece, make sure you smash it. If you want to look at the sun with naked eye, you can buy these special glasses. They cost about $2 or something. There's special glasses for looking at the sun. It's perfectly safe. You can stand there and you can look at the sun. You won't see much, unless there's an eclipse of some sort. You won't see sunspots generally, but you can look at the sun and it's perfectly safe. And I've got 3 or 4 pairs of them at home. So you just have to remember with telescopes, size does matter. The bigger the better. And if you're really keen, you can never have too many telescopes. Right? So